Hello there. This video is going to show you how to run a multivariate analysis of variance to examine the effect of two categorical independent variables on numeric dependent variables. So here we have our data, and we're going to specifically look at analyzing data with the general linear model multivariate analyses. So for this example, we've got three different conditions of a belongingness intervention, will be our fixed factor, as well as I'm going to look at different age groups. So we've got traditional versus non-traditional students. Since these are categorical variables, we're going to put them in as fixed factors. Then I'm going to select my dependent variables. So we're looking at excitement about joining the online program, anticipated belonging, prospective belonging uncertainty, perceptions about faculty support, how much faculty understanding they think they'll have, and the anticipated difficulty of transitioning to the program. Those are our dependent variables. When I look at my model, we want a full factorial model. That means we're going to look at the main effect of condition, the main effect of age, and the interaction of the two together to see if the impact of the condition depends on age. Then we're going to go in our options, and we want to see the means for the condition by age for the interactions. We also need to make sure that we have the estimates of effect size, or eta squared. All right, let's make sure there's no other options that we want to look at. We're going to keep it kind of simple. All right, so if we want to do a post hoc, we can do it based on condition, and we can use a Bonferroni. All right, here we go. So if I look at this, this tells me my sample size for each group. I have those three different conditions, and then two different ages, traditional versus non-traditional students. Here's the overall multivariate test that looks at everything all at once. We can see there's no values less than p equals 0.05 here, but I'm still going to look at the test of between subjects effects. So if we look here, I start with the significance column, and we can see, going to condition, there was no significant difference in these dependent variables based on which condition students were randomly assigned to. But if I look here at my sigs, my p-values, I see based on age, there was a significant difference. We see here, prospective belonging uncertainty, p less than 0.05. Also here for faculty support, anticipated faculty support. And then this is approaching statistical significance. We would call that marginally significant, anticipated difficulty of the transition. If we look here, we can also see we have some significant interaction effects. So this is less than 0.05, right? And that's our sig, our p-value. So we can see that the impact of the condition on prospective belonging uncertainty depends on the age of the student. Are they traditional or non-traditional college student? Same thing with the anticipated difficulty of the transition. Now, to interpret these results, it's helpful to look at your means here that we requested. And so here we are able to see, based on condition and based on age, those different means there. And that's really helpful when it comes to trying to interpret what do these results all mean. Also, if we look here, I don't see any means overall. So let's do another request. I'm going to go to Analyze, Compare Means, General Linear Multivariate. Let's also get the descriptive statistics. Let's see what happens when I do that. Now we've got some helpful stuff. So this is helpful because now we can look at the total mean for the condition regardless of age. And we can also look at the total mean for age regardless of condition. And those are right there. So that's really helpful as well. Now, I requested post hoc analyses for condition because there were three different conditions. And so I wanted to know if there was a significant difference there, where those significant differences lie. So that would be here. And you can see that none of these are significant because overall none of them were significantly different. And if you wanted to know which ones were being compared, you could see here, this would be the significance of condition 0 compared to condition 1, and then this would be the significance of condition 0 compared to condition 2, and so on. All right, I hope you found this to be useful in looking at multivariate analyses of variance when you have 2 categorical independent variables and several numeric dependent variables.